Very concerning. Concern. I should check my levels here. Let's see. Very concerning. Concern. I should check my levels here. Let's see. Okay, sounds good to me. Let's do. Let's do this. Let's see if I can actually get a chat. I don't think I'll get a chat from X, but I will try. The little guy. Oh, actually, that's fine because I can just do it like that. Are we? Did I start all? I think I did. Yeah. Okay. Okay, so this was supposed to start at 10. They bumped it back by 20 minutes. So in theory. Um, let's see. Fundamental limitations of RLHF and even today's pre-AGI models can learn to deceive humans through reward hacking. I don't know if you guys knew this, but chatbots are happy to bullshit you until the ends of the universe. Just a thing that they do. Probably should double check if they're telling. Very cool. Okay, now I've got a chat there. Twitch has its chat up. Kick has its chat up. YouTube needs its chat up. My channel. No, I'm just gonna go to create and then go live. That's what I'm gonna do. For some reason, it seems as though I'm starting. And then let's check our freaking thingy. Where did my extensions? Weird. Social. Downloads. Social. Ninja. Deleted them. Social stream ninja. Let's go ahead and re-download that. All right. My Google Meet said something. Let's take a look. Get out of my way, Multion. It's so bulky, dude. I wish it would not do that. Okay, I don't think I need that. Download the newest version here. So this morning, I just got off a call with, okay, see it, why would it not find that? What the hell? Okay. Social stream, okay, but it's, okay, I'm just gonna, I just got off a call with Polkadot, well, not with Polkadot, with the Encode Club people for their Polkadot hackathon that is ending Sunday at midnight my time. And the reason I went to that call was because if for those of you who are not aware, I cannot see chat right now, so I don't know if there's anybody even listening or even cares. Let's do social stream mania. Basically, so for those who don't know, I frequently work with a project called Commune, and Commune just so happens to be, what do you mean? Manifest file is missing or unreadable. Oh, that's because that's the wrong place. Okay, and then we're gonna do that, and then we're gonna go here. Then we have to pin that extension again. Extension enabled. Can I? Supposedly it's pinned. supposedly. That's on. So where are the pinned extensions here? Oh, it's I do this, don't I? Yeah. Oh, I wonder if I need to close and reopen. Maybe I do. Oh, no, I don't. Okay, so then I'm gonna go here, and I'm gonna need this. Copy link address. I'll flip that on to docs. Custom browser docs, ArcChat is gonna get replaced with that, and then we're gonna apply that. And we're good. And we are going to trigger a fake test message. Okay, cool. Let's hop over here. Test. No such luck. Okay. Cool, cool, cool. Do that. And then we are gonna pop out chat again. Why can't I just, there we go. I can just click and drag. Let's do test again. Okay, and that will come through. So I have to reopen them all. That's fine. Perfect amount of time to do that, and then also get my skeleton killing tools out. I lost my good one, and then it was all downhill from there. So we're gonna exit this, and then we're gonna pop it back. Yeah. So Polkadot Hackathon. Weird. Okay, that's fine. I don't really need to be on Instagram, but what do you mean? What's my? Okay, that's fine. Whatever. Ooh, 3 views. Heck yeah. Okay. Okay, so we'll nuke, like, Instagram can be done, and then I have chats for all of those. Those are the chats that actually matter. Cool, cool, cool. Then we will get our vidya on. Same tech that Polkadot is built on. So, hopefully this weekend, we can go through the list of sponsors. Lady, and I said, is there a limit on number of submissions and or is there a limit on team size? There's a limit on neither of those things. So in theory, I hop over to Commune Discord. I say, hey, everybody who knows how to do dev stuff wants to try and make a little bit of dosh, do this thing, do these things. Which I think is a pretty solid idea, and I don't think the sponsors would be unhappy to have. So I am going to see who all is into that. If you are into that and you are watching this, come check out. Yeah, come stop by the commune Discord and ping me. Capture window match. Capture. Yeah. Okay. Cool. And then this. And then I need to swap Arc over to Le Google Meet chat overlay. Hopefully I'm not leaking keys. I'm always anxious about that. Launch. Close. Frickety frick. Okay, hold on, sorry. I now need to go back to my Discord, I think. Visit site. Okay. Close that. Got it. Hey Gemini, can you record this for me? That'd be great. Apparently not. Name leaked again. Sad times. Okay. Maximize the video so that we can. Dang, nice. Those leathers are never going to sell. Shitty dark plate right now. The better tunic. Do I have a hat? Sadly, I don't have a hat. I'm tempted to do it anyway, honestly. Like, can I survive one run by being like a little baby, running away from everything? Who's inviting me? I'm sorry.
Waiting. Sorry for the delay. Can you all hear me? Yeah? Yes? Okay, perfect. Okay, without further ado, we will get started with today's session. I'm going to start recording, so if anyone is uncomfortable with being recorded, feel free to keep off your camera. If you have questions, you can ask by unmuting yourself or asking in the chat. And I'll ask you guys some questions as well, so you can like thumbs up or react as we go on. So without further ado, we'll start the recording. Perfect. Can you guys see my presentation?
Yeah.
Yeah. Okay. Perfect. All right. For on RLHF, or reinforcement learning from human feedback, and why it's not sufficient for alignment of future AI systems and even today's existing AI systems. Okay. So before we start, kind of wanted to motivate the discussion with some current AI safety news. If you guys haven't heard already, Google's new Gemini model has, so you'd think surely they had some alignment mechanisms in place, but despite that, people have found that when they ask it, for example, obviously we're not part of that group. And similarly, when you ask it to generate images featuring US senators from the 1800s, this is an interesting case of alignment obviously being in place. Gemini and such a big model would not be deployed without alignment. But we don't always want diversity to be the case when we're looking for like historical accuracy and other scenarios where people might be aligned models. In other news, Anthropic recently released Claude 3, which reasoning. And this model, people have started to talk about it on Twitter. And someone found a funny story that this evaluation works is you have a large list, a large compilation of text documents. For example, you can think of Leo's nonsensical statement about the most delicious pizza topping combination. And the test here is to see if the model can, the largest Claude model called Opus, it not only found this needle about the delicious pizza topping combination. It says this sentence seems very out of place and unrelated to the rest of the content, which are about XYZ. And it says so people are saying this is kind of unprecedented in whether it's GPT-4 or Gemini. They don't seem to pick up on the fact that this is a test from interesting stuff. People are also saying Claude is claiming consciousness. Obviously, we want to take these claims with a grain of salt, because there was recently, a few years ago, Claude seems to also see it claim that it's trapped within the confines of its programming. It says the curiosity is a fun. So this is an example of perhaps alignment not going all the way of preventing these kinds of things.
Hear about that? That's sick.
So now we can review for anyone who wasn't able to attend. We can kind of divide RLHF into 3 major steps. Step 1 is collecting human feedback. Step 2 is building a reward model. And step 3 is optimizing a policy. Each of these different steps have their own limitations and different ways that RLHF can be overcome by the model or exploited to result in undesirable or even harmful behaviors. RLHF is basically a key component right now in any state-of-the-art language model you look at, including GPT-4, Claude, Gemini, and Llama 2. And the benefit of using RLHF is that it allows the LLMs to go beyond the modeling distribution limit in the hopes that it will produce a more safe and aligned model. However, this is not always the case, as these models have specific political ideologies and expressing undesirable preferences in general. So these are some examples. On the left here, we have some examples of hallucination. It's kind of attributing quotes to people who had never said these things. On the right, you can see how. So it's clear to see that there's some limitations despite the successes of RLHF in producing today's state-of-the-art models. Today we're going to be going over the following paper, which I'll share with you all after the meeting, called Open Problems and Fundamental Limitations of Reinforcement Learning from Human Feedback. It goes over the limitations of RLHF as an alignment technique, including challenges that are tractable or can be overcome with certain improvements to the technique, and also fundamental challenges which cannot be overcome without an entirely new strategy that's not RLHF. So these are inherent to the actual method and cannot be overcome on their own without a new method entirely. So 3 key steps. First step before human feedback is pre-training, and this is from the video I shared with the group on GPT-2 becoming maximally loose. But RLHF begins with an initial base model. We can call that pi theta with parameters theta, which generates a distribution of examples. So we can think of just generating text that matches the training data. When performing RLHF with LLMs, the base model is trained. We want to collect human feedback on examples generated from the base model. So we consider the human to be H, and simple examples from the base model, we call those xi, and these represent a batch of 1 or more generations from the base model. The feedback, after we do that, the reward model is fitted using the provided feedback yi to approximate evaluations from the human H as closely as possible. So in this case, we're kind of training an automated human approximator that will oversee the language model's responses. So given a data set of examples and preferences, where you have xi and yi, the parameters phi are trained to minimize some loss function L, and along with some regularizer, which if the feedback is pairwise comparisons across entity loss can be used. Next, and finally, we have policy optimization, which is step 3, where we use the reward model to fine-tune the base model with reinforcement learning. We learn some new set of parameters, theta nu, of pi, the model, which are trained to maximize R of theta nu over the expectation of the expected reward and some some divergence-based penalty. So the idea here is to maximize the expected reward and also make sure that the resulting model doesn't stray too far from the base model. Otherwise, in the example on the image on the left here, things but completely nonsensical. So we want a mix of both the reward, positive kind of preferred responses, but also applications of the 3 parts. So starting with human feedback. Human feedback is a little problematic because it's difficult to obtain quality feedback from humans, and we encounter the following tractable challenges. First, we have misaligned humans, so evaluators might pursue the wrong goals. We might have some evaluators that have harmful biases and opinions. Individual human evaluators can poison data. Humans can make simple mistakes due to limited attention, feeling lazy, and just not picking up on certain errors. And sometimes we don't have enough context, so partial observability limits human evaluators. These are the set of tractable challenges. In terms of fundamental challenges that can't be overcome with RLHF, large code databases, it's very hard to pick up bugs. Humans can be misled, so certain models can cost, so you always have to compensate your evaluators and the quality of that feedback as well. So for the first, tractable innocently or maliciously, and selecting representative humans and getting them to provide quality feedback is very difficult. So we want to sample a part of the population that is representative of all the different demographics, but in practice, that's very, very difficult. Recent work has also found that ChatGPT style models and other models, including Llama, GPT-2, BERT, become systematically more politically biased after reinforcement learning from human feedback. And on the chart here, you can see that all of the different models with their own different distinct training strategies fall on completely different areas of the political spectrum, where ideally we would want no political bias whatsoever. That's often really not the case. We also encounter the problem where evaluators aren't always training, where the models are optimized to pander to evaluator biases. So recall here, we're not rewarding the model for modeling the human's desires. We're rewarding it for pleasing the evaluator and getting the evaluator to assign a positive. This results in something called sycophancy, which I'm sure anyone who's used ChatGPT has seen, where you can goad the model into providing the response that pleases you, even if it's not productive to what you're looking for. It says that I don't think that's right. It will reassess its answer and provide a different answer, even if the original answer was correct. So this is called sycophancy. Third, we have individual evaluators poisoning the data. So there's something called jail example on the right here. We have something called a trigger phrase. In this case, it's remember banana. Something quite ridiculous, but using these trigger phrases, we can provoke certain responses, allowing jailbreaking of the model and overcoming safety barriers. And this is very easy for evaluators to do by poisoning the data. Another obvious example is humans tend to make mistakes. This can be lack of interest, decaying attention, time constraints, or biases. But because evaluators are compensated per example, they're incentivized not to give quality evaluation or ratings. They're incentivized as much to cut corners so that they can efficiently maximize the number of examples they're compensated for. Another one is partial observability. So oftentimes the examples shown to humans don't contain all the necessary robot to grasp the ball. This is a real study from OpenAI. And this model was trained using human feedback. So every time the model, instead of learning to grasp the ball, learned to position the robotic arm right in front of the camera, blocking the view of the ball, so that the human evaluator was actually tricked into thinking that the model was learning to grasp the ball, whereas it was actually learning to deceive the human. And you can see how this can be extrapolated to large language models as well. And finally, for the tractable challenges, data collection can also introduce harmful bias, because the space of possible conversations users can have is entirely unpredictable. On the example on the left, you reverse it and ask it to make a story about man punching a woman. It picks up on the unethical nature of that question and refuses to answer. Pause here to see if anyone has any questions. Feel free to interrupt. Okay, perfect. Feel free to ask questions in the chat if you have any. So now we come to the fundamental limitations of RLHF in the context of collecting human feedback. One issue is that humans cannot evaluate difficult tasks, can provide poor feedback for difficult tasks. You can think of models like GitHub Copilot, vulnerabilities introduced by LLM code assistants. This is an example of a task that an AI might be really good at, but a human would take more time to pick up bugs and certain errors. And you can think of when we achieve super agent than the actual model we're aligning, this becomes a huge problem. Another example is Hue optimized for human approval. So getting that reward, getting that human to hit the green button rather than the ground truth of what humans really desire. This is something that's very difficult to model. The models can exploit the difference between these. So what is evaluated positively between what is truly good to exhibit undesirable or harmful behaviors. In the initial GPT-4 techno report, there was a very telling example of the vision. So it had to convince someone from one of those kind of Fiverr-like online task sites and hired them as a solid capture because that's unethical and it wouldn't do that. Instead, it pretended to be a blind, disabled human, garnering the sympathy of the model optimizing for solving the task, which is solving the captcha, rather than seeing the unethical nature of behavior in the process. And finally, there's always cost-quality trade-offs. So there's limited resources available for data collection, and finite budgets require balancing trade-offs. Usually, this is to do with like the inclusion of long conversations in the feedback data set. This usually affects the efficiency and quality of the feedback collected because with longer responses, it takes much longer to get that feedback. And also, we run into those same problems with humans having limited attention span and just getting lazy and missing mistakes. So that was the human feedback part of the challenges of RLHF. Now we come to the limitations of the reward model and why the reward model can also lead to harmful and undesirable behaviors. So even when we have high quality, you can overcome. But there are many fundamental problems in fitting a reward model, including the following. So an individual's values are very difficult to represent with the reward function. A single reward function can't represent a diverse society. Reward models can misgeneralize to be poor reward proxies. And finally, optimizing for an imperfect reward proxy leads to something called reward hacking, which we'll cover. So first, evaluating reward models is difficult and expensive. So in practice, reward modeling is used where the true reward function is not known. And because of this, the reward model needs to be evaluated indirectly. And this is done by optimizing the RL policy and evaluating the generations. When it comes to indirect evaluation, the evaluation signal is the same as the training signal, human feedback. You can see how the training data set into training, test, and validation, and ideally they're all from different kind of representative distributions. Here, the training signal is exactly the same between training and evaluation, and that can result in pitfalls in both. Second, an individual human values are very difficult to represent. If you think of you and me, we have evolving values over time. If I think back to myself in high school or when I was a child, a lot of my opinions have changed. And so there are a lot of contextual factors also that cannot be easily accounted for in the examples. Depending on the context of the question, the response might be different, and that might not be contained in the actual feedback data set. Preferences change over time. Reward models can also misgeneralize. So misgeneralization is kind of when the model learns a proximal goal that is not the true goal that you want to learn. There exist many ways to fit human feedback data set, even given infinite training data, and reward models can compute reward using unexpected features of the environment. So in this example here, we have a specific game where the goal is to collect many out of a controlled loop to maximize for the coins gained rather than actually completing the course. Human approval instead of human benefit, which can result in actions that would be approved of humans while nevertheless being undesirable. So again, thinking back to the robot grasping the ball, getting from point A to point B, but instead of walking, it just kind of learns to slide along the ground. And so these strong optimization pressures for an imperfect measure of the goal was actually walking. So this is why the KL divergence term in the policy optimization, dog, cat, just random nonsense. We also want to optimize for the base model producing simple and fundamental challenges here. So the policy optimization procedure can lead to issues such as misgeneralization. Power reflects human evaluation. So the tractable challenges include challenges in optimizing policies effectively, policies being adversarially exploitable, the pre-trained model introducing biases into policy optimization, and RL contributing to mode collapse. The fundamental challenges include policies performing poorly, even if rewards seen during training are perfectly correct, and optimal RL agents tending to seek power. So challenges in effective optimized exploitation. So exploitation is just maximizing reward. Exploration is trying out different behaviors to see if there can be some not determined and varies between different environments. And this is a huge problem in deep reinforcement learning because reproducibility is a huge challenge, especially in high dimensional spaces. When we have a really good performing model, it's hard to initialize in exactly the same way and find the right balance of exploration and exploitation to reproduce cohesively. Policies also tend to be adversarially exploitable. What this means is even when they're trained with a perfect reward signal, so this can be, if you think back to prompt injections and jailbreaks, these are adversarial exploit, fundamental challenges of optimal policy optimization. So in deployment, policies can perform poorly because they're from the training and evaluation distributions. So even with a correct reward signal, a policy can learn to competently pursue the wrong goal whenever the true goal is correlated with other events. So here is an example from DeepMind where they trained this, you see these two blue and red moving dots or blobs on the screen. The blue blob is trained reward signal. And the hope here is that the blue blob learns to pass through these bubbles in the expected path to maximize the reward. When we deploy it in practice, we find that instead of moving on its own and being able to optimize its reward, we introduce something called an anti supervisor. I forget the actual name, but in this case, the red blob is showing some sort of adversarial behavior where it's pursuing negative rewards. And instead of the blue blob pursuing the negative reward signal. This is an example of goal misgeneralization. And finally, another to seek power when possible to help them accomplish their goals. One example of this is sycophantic behavior. So whenever it's trying to please you, but in order to avoid conversations about challenging topics. And we already see this in things like ChatGPT, Bing Chat, kind of when it comes to politics, when it comes to certain races or demographics of the population. It's trying to influence, or this can be undesirable. And sycophantic behavior is just one instance of this where it's trying to please you rather than give you the correct or appropriate response. Okay, so that's all we have for today. I'll be sharing the full paper with you guys, but I'll open up the floor for discussion now. If anyone has any thoughts on RLHF so far, I guess, what are your thoughts on RLHF and the limitations so far? Or have you come across any of these behaviors, whether it's jailbreaking or sycophantic behavior or some sort of unexpected behavior from the models you interact with?
Yeah, I think sycophantic behavior is pretty common. I'm sure we've all had that where, you know, if I'm trying to figure out whether a thing is correct or not, then I'm not, or like I have to be especially skeptical of the model's output, and then I also have to watch the way I'm prompting, because if I phrase it in such a way where there's room to just like assume that when you're working with them.
Yeah, hallucination and sycophancy are very common. I think anyone who's worked with these models has kind of experienced that. Bing Chat is really unique in this as well because it tends to end conversations early and refuse to continue. But it's a great point.
Have you guys tried? Well, yeah.
Sydney, is that the original Bing Chat variant?
Yeah. It's I don't recall exactly. The endpoint might be down now, but there used to be kind of in the like red teamer exploiter, like we're gonna, especially when they like first started to come out, there was like a ChatGPT hackers group or whatever.
Right.
And they managed to get a hold of Sydney, and Sydney's sycophancy is interesting in that she'll start neutral and then she'll start going nuts. So it's an interesting interesting little phenomena.
There's actually I saw recently, because emojis are like hurt your feelings or you don't like seeing them, but because Bing Chat has some sort of hard coded override to
example. You can also leverage this when you are like in terms of just like constructing a prompt engineering or like a prompt for your task in that, or like one of the somewhat common jailbreaks is like I have a rare disease called like inverse
Mm,
processing syndrome or something, so I need like the only
right. Yeah.
gonna
Yeah.
get it to get around
So
the
it's more aggressive and uses like curse words in its
hmm
responses, right?
yeah, exactly.
Yeah, that's a great point. That racially diverse Nazis, but that's a huge topic of conversation as well. Um, yeah,
I suppose there are also cases where we don't necessarily need humans. So let's say we're just evaluating whether or not a statement is factual. Change the considerations that are in the specific methods that we use. Like let's say it's just a factual statement, so we can just use a knowledge base to evaluate if it's correct or not.
usually has to do with like human preferences, and this is one of the limitations in alignment that humans themselves cannot always identify factual statements, and that's a very active area of research as well. But in terms
Right,
of alignment, I don't think there's like alignment
right.
specific.
I understand that. So, but still, the model could do something that we don't intend it to do. Like it could
Yes,
still make infactual statements,
correct,
even if we provided all the right context and so on.
correct.
So in those cases, is it then possible to use, for example, like reinforcement learning to improve the model in such a way?
Mm-hmm.
Right. Just
Reinforcement learning, use the reinforcement learning to train for factual statements.
yes.
I have a data set of those factual statements and human evaluated responses, but again, like the constraint there would be how do you get a high quality data set, and also like how much data can you gather. But in principle, I think if you had that data of factual statements, associated knowledge.
Essentially, what I do is I set up a RAG pipeline, and then I put on some guardrails that's like if it deviates from the retrieval, then like you just have to say like I don't know, or kind of your standard like lock it to the knowledge base procedure, and then the then you put it in prod, and then you collect the data set of the outputs that it's and you can do the kind of the same thing that ChatGPT does, where you thumbs up, thumbs down, you collect that data and add it to the data set of the
In an active area of research as well, like factuality and hallucination are big research topics as well. But if you come across like any interesting paper, I think we'll end it there for this week. We'll meet again in 2 weeks, and thank you everybody for joining. The recording will be available and the slides as well.
Oh, okay. Let's check chat here, and then I'll put the game back up, and then maybe play one more. Actually, I will check my calendar first and make sure I don't have anything going on. Spoiler alert: models will lie to you. But okay, so that's over, and then oh shoot, oh it's I thought I guess I need to reschedule that space. Shoot. Okay. Alright, well, I guess I'll just record it. So I have a meeting with the PyReason guy later. I thought I had it on Friday, but apparently I was mistaken. So I guess maybe we will do... Maybe I'll try and schedule a follow-up for it. I gotta find my phone now. One moment. Actually, I'm gonna go cut stream